All right, so we're recording now. The Abaqus window has opened up, and I'm going to start with the creation of a standard simple model database. So as you look in the Abaqus, as you launch Abaqus, you'll see that there's a big menu bar up here top, and then there are some icon-based menus here. As you can see, we'll walk through them as we get time. And then there's another icon-based menu on the left-hand side. And it's really all comes down to looking at the modules. Uh, in order to develop this model systematically, we'll go from part to property to assembly to step, interaction, load, mesh, and so on. So we'll go down these individual modules. So let's start with the creation of our part. And what I'm going to do is click on the part manager, and I'm going to say create. Now this is going to be a 2D model as stated in the problem. It's a simple shear wall, and it's a 2D planar model of a shear wall. You can call it that. It's going to be a deformable model. It's not rigid in any way, and it's going to be a shell, and its approximate dimensions are 180. As you know, it's 120 by 180 inches. I press continue, and it shows me a generic grid, at which point I'll dismiss the part manager. Now I will zoom out so you can look at this whole grid that has been created. Now I'm going to make the simplest model in the world, right? So I'm going to make a rectangle. So I'm just going to click on the, so now that I have given it some information, it has given me some drawing tools in this portion where I can draw points, lines, circles, rectangles, and so on. I'm going to start off with drawing a rectangle, and it's asking me to pick a starting corner for the rectangle. And I'm going to just enter the coordinates -60, -90. And then it will want the other side of the rectangle, and I'll give it the coordinate 60, 90. And there, that generates the rectangle that I'm going to be working with. As I mentioned in class, the model that I'm building has slightly different dimensions. The dimensions are transposed as opposed to the dimensions you'll be using for the homework. But that's the rectangle. I've provided the two. So at this point, I will say cancel procedure, and I will say that I'm done with the sketch for the planar shell. There you go. That's the simplest model that has come into existence. It's a 2D model. I'm done defining the part. So at this point, I'll go into defining the property. Now the property, the first thing is it wants me to define the steel or the material model. I'm going to define a material model for steel. And I'm going to go to the mechanical behavior and look at all these options that are available. And we'll talk about only the first two probably, because elasticity is where we are at right now. Later on, we'll move into plasticity. Just look at how many options are there in plasticity itself. There is general plasticity all the way on to concrete plasticity and so on. And then there are, of course, damage models. We won't talk about these damage models. These are typically needed for fracture simulation and so on. And then there's, of course, damping and expansion and the brittle cracking model. We won't get into any of those. We'll just talk, right now, we'll stay in the elastic world. Even in elastic, you can notice that there is elasticity, there is hyperelasticity, there is hypoelasticity, viscoelasticity, and so on. There's several options. We're going to go with the simplest one, which is this elastic model. And it asks me what type of an elastic model it is. In that also there are options. There's isotropic. You can make a FRP made up of lamina. You can have orthotropic and isotropic elasticity. Well, we're in the simplest problem, so it's isotropic elasticity. I'm going to specify the E to be 29,000 KSI and the Poisson's ratio to be 0.3. So the units are self-consistent, which means that when I start using kips and inches, my whole model had better be in kips and inches. There can't be any feet anywhere. Yeah, it has to be all in kips and inches. Okay, the elastic material has been created. At this point, I'll dismiss the material part, and instead I'll go to the creation of a section, and I'm going to create a solid that is homogeneous. I'll call it the steel plate. Homogeneous steel plate. I'll press the button for continue, It understands, it's asking me what material it is, and it is picked the option for steel, which is the easiest way to go. And I'm going to specify that it's a plain stress thickness of 1 inch. I click OK. Now I've created the section, but I haven't assigned it to anything. So I use this icon to assign the section. It's asking me to select the regions to be assigned. It always asks the questions at the bottom there. It says select the regions to be assigned a section. I select this region. I click done. And it will come back with the options for what I can assign to it. Yeah. So it's telling me that I have, well, I really have only one option. I've only defined one section. So it's going to be associated with a steel plate, which is a solid homogeneous. This is an assignment from a section. I click OK, and the color changes, and the section has been assigned at this point in time.